Hi, this video we're gonna start looking at shape that we can solve finding the centroid using integration method. And you might already know from the previous video or you just know for a triangle, a right triangle, the centroid here we said it's going to be here is going to be 1/3 of b, and the height is going to be 1/3 of height, right? So we know that, but here, this video, we're just targeted to solve this. We're using integration method to prove it this is true. So in order to do that, we're going to draw our rectangle here and put them into XY axis. So this is gonna be our base B and the height H. And now we're actually gonna focus on this line here, because we're going to actually consider this line. We're going to integrate this line. And this is going to be a linear line. It's going to be y equal to, let's see, kx plus intercept. And I'm just going to write down intercept. So how do we find our slope, our k, and find our intercept? So there are a couple of ways to do it. And if it's most general way, you're going to find those two dots here, because those two dots are on this green line, and this dot, let's read that coordinate, is going to be on y-axis, so it's x, 0, h, and this is on the contrary, it's on the x coordinates, is b and 0. Then we're going to be able to solve it. Here I want to go ahead, plug into this equation. So the first bring 0h in there. So what do we have? X equal to 0. So y is equal to h. So y, because 0h satisfies this equation, right? Satisfies this x and y. So h is going to be equal to k times 0 plus intercept. Then you immediately solve it. This intercept is going to be equal to h. So that's going to be equal to h. Then bring up to the second equation, second point, b0 to satisfy that equation. And our y, now it's 0, right? And our x is b, so it's k times b plus our intercept, which we already solved in the first equation. Intercept is equal to h. Then remember what we're solving? We're solving the slope, we're solving the k. Because b and h are base and height, which is given. K is going to be equal to negative h over b. So you find this equation, then let's plug our k and intercept into the equation. Y equal to k is negative h over b. The reason it's negative, we know, because it's what? Decreasing. Then times x, then plus intercept h, okay? All right, so that's our first step to get an expression for this green line. We figured out the slope, we figured out the intercept, so that's our step 1 to solve a problem like that in order to find a centroid. You know, the line expression is first step. Then once we have that, we're going to look at our next step. We're thinking about the equation. In order to find the x bar, we will have integral of dA, and we'll have integral of x bar and dA. Now be aware, x bar is going to be this differential element area centroid. So here you have a choice. Remember in calculus, we work on integration. You go ahead and draw that differential element in a rectangle form. You can either draw vertical or horizontal. Here, obviously, this is a vertical one. This is going to be this purple. It's going to be our dA. That's area. Then the x tilde right here is going to be this dA, this purple rectangle centroid. You know, rectangle centroid is going to be right in the middle, right? You may argue this is not a rectangle since it's slanted, but we're looking at differential element, so it's very small. Then when you divide up so small, that's going to be considered as rectangle. Okay, so that's going to be the centroid, this red dot, the centroid of this differential area dA, and we need to find out its coordinate. Okay, so in that situation, we needed to write down x tilde and y tilde for this red dot. And for this red dot, we're going to write down. So here, what we cut, it's arbitrary. So that's going to be, in terms of that, x coordinate is going to be x. Okay, and our y coordinate is going to be the y here, because this is y, because at that point here is x and a y, that dot. So this is y. If that's y, then this coordinate will be half of the y. So it's y over 2. Okay, we have x tilde and y tilde. Now the next thing we need to figure out is dA, the area of this purple rectangle. So what's the length here? It's no longer x. X is from here to here, and this, however, is going to be dx, right? Because it's differential element. And the height, however, is going to be this height, which is our y. Then our dA, this rectangle area, it's length times height, so it's y times dx, y dx. So dA is going to be y dx. Okay, so that's our step 2. We figured out those. Now we're going to solve it. Our step 3 is x bar is going to be y dA. It's going to be equal to our dA. Integrate of all the area, and the numerator is x tilde dA. X tilde for this particular problem, we already know, is going to be equal to x. So plug that in. dA, we already know it's y dx. Plug that in. Then for the bottom will be just y dA, y dx. Okay, that's our dA. Now, that's why step 1 comes in handy, because step 1, you get expression for y as a function of x right here, right? The expression, so we can plug it in. So we'll have, maybe there's no space here. We'll just write down y is going to be negative h over b x plus h dx. And the numerator will have x and y, negative h over b x plus h dx. Okay, so that's what we have now. We are going to integrate, and our range for x, because we integrate about x, what's x range here? Is going to from 0 to b, right? That's our base. So from 0 to b. All right, let's go ahead looking at the bottom one. Just think about the bottom one is basically what you're doing here. That's basically the area of this triangle, right? And that should be equal to what? Half base times height, right? And we always learned area of a triangle, half base times height. And here you can use integration to prove it. So you can prove that is indeed equal to half times base times height. So why don't we do that? Why don't we just looking at the bottom, integrate the bottom first. So that's going to be equal to the first term, integration, is going to be equal negative h over b, that's constant, x squared, then divided by 2. The second term, h, will be just hx. Then all those together have a range from 0 to b. Then we can put that in there, or you can just say this is 0 to b, and this is 0 to b as well. Then what do we have there? The first one is h negative 2b, b squared minus 0, so it will be just b squared. The second term will be hb minus 0, just b. Then b and b canceled out. Then we have negative bh over 2 plus bh. Then we will have half bh. That's going to be rectangle area. We proved it using integration. Now, let's go ahead and solve the numerator. So for the numerator, what do we have? The first term is going to be negative h over b x squared, right? Then when you integrate that, that will going to be negative h over b x cubed over 3. Then the second term is x times h, so it will be hx. That will be hx squared over 2. And that range is 0 to b and 0 to b. Now first term, we'll have negative h over 3b, b cubed minus 0. Second term will be half h b squared. Again, b, that canceled out. Then we'll have negative b squared h 3 plus b squared h over 2. Then common denominator would be 6, right? So this would be 6, this would be 2, this would be 6, this would be 3. So end up with 3 minus 2. We'll have b squared h, just one of them. So we have both of those answers. We'll bring back to our step 3, because that's, you calculate, is b squared h over 6. And the numerator is half bh. So the x bar is going to be, right, h canceled out, 1b canceled out. So then we'll have b over 3, because it's 2, 6. So b over 3. That is our b. And that's exactly what we have been using for triangle. It's going to be 1/3 of b. Okay, 1/3 of b. So we find our x bar now. The next thing you want to solve is, it is 1/3 of h. And what would be the formula for that? Will be y bar is going to be equal to integration of dA. And here we'll have y tilde dA. Right? And here you don't need to solve this again, which you already have done in the step 3. You already proved the rectangle area is half bh. So the only thing you want to go ahead and solve, it's just, this top part. And what is that going to be equal to? Because we know y tilde from step 2, y tilde, you already figured out, is going to be the centroid, this rectangle centroid right here. The coordinate is half y, so half y. And our dA, you also figured out from step 2, is y dx. Right? So you have that. So essentially, that's going to be half y squared dx. Again, you can, and we have to, bring this y equation there. Right? Y equation is negative h over b x plus h. That's our y square dx. So that's how we're gonna go ahead and integrate that term to find the, so which we're about to do. So integration that, take a half out, right? It's a constant. So inside here, the first term will be h squared over b squared x squared. Because we know, here's a little quick math there, a plus b squared is a squared plus 2ab plus b squared, right? So that's what we're doing here. It's going to be minus 2hb to h squared b x, then plus h squared, then dx. All right, now we are going to go ahead and integrate that. Then the first one will have h squared b squared x cubed over 3. The minus, second one will be 2h squared over 2b x squared. Second one will be just h squared x. And all of those are going to have integration from 0 to, again, b. X range is that. So when we have a half, the first term will have 3b squared h squared b cubed. Second one, 2 and 2 canceled out. We'll have h squared b squared. Third term will be h squared b. Then go ahead cancel as much as we can. Then in the parentheses, they all have bh squared. First one is 1/3. Second one is just bh squared. The third one is also bh squared. Then those two canceled out. We'll get 1/6 bh squared, right? Now we go back to step 4 here. We already solved this just now. It is 1/6 bh squared. Then we can go ahead and solve this final answer. What's y bar equal to? We have 1/6 bh squared over half bh. B canceled out, h canceled out 1. So we will have just h. And 1/6 divided by 1/2, that will give us 1/3. Again, we got this fantastic 1/3, right? You, from this example, you use integration method to prove the triangle. It is indeed third b and third of h from the fatter end. Alright? Alright, so that's all for this video, and I'll see you next time. Bye.